This is paper 3, video 5 for the February mock. The first question we're going to look at is this, so finding missing angles. Now in this sort of question, you're more than welcome to do all of the working on the diagram. So the first thing that I'm going to pick out, if I cover up this bit on the outside, the first thing I pick up is that within this circle, we have got this kind of bow tie shape. Now one of the circle theorems states that same segments have got the same angle. So what we've got from that is that this angle here is also 42 degrees. These two angles at this side will also be the same, but we need a bit more information to find that. Now the next angle that jumps out to me, if I cover up this section, is the fact that here we have got an isosceles triangle. The reason I know this triangle is isosceles is because these little dashes mean that this line and this line are the exact same length. So if this is an isosceles triangle, in order to work out these two angles here, I would have to do 180, take away 42, and then divide that by 2. So if you do that, we get an answer of 69. Therefore this angle here is 69, and this one here is also 69. The fact that both of these triangles must be identical, because again, 42 degrees and it's isosceles, we've also got that this angle here is 69, as is this one. At that point, the next angle that jumps out to me is this one just here. Now there's a couple of ways of working that one out. The one that jumps out to me first off is the fact that this 69 and this one that we're looking for here, those two join together to form a straight line. So these two will add together to make 180. If I do 180, take away 69, that tells me that this angle here must be 111. We've now got this shape, this kind of kite-looking shape here. Now that is a four-sided shape, and we know that all four-sided shapes add up to make 360. So if we actually write a little equation showing that, we've got that 111 plus 2x plus 3x plus 44, so the four angles inside this quadrilateral, they all add together to make 360. At that point I'm going to neaten up and then try and solve this equation. So 111 and 44, we get 155. 2x and 3x make 5x, and that, as we said before, equals 360. So solving this now like I normally would in an equation, I'm going to take 155 away from both sides to give me that 5x equals 205, and then I divide both sides by 5, leave me with x is equal to 41. It doesn't say I need to do anything else with the question, simply find the value of x, which I've done. The next question is all to do with upper and lower bounds. So we've had a little bit of practice at this earlier in the paper, so hopefully this should go quite quickly. So Mr. Smith's doctor has told him that he cannot carry any more than 40 kilograms. We've got a delivery that has been sent to reception of 50 kilograms to the nearest 10 kilograms. Before I do any calculations to do with the actual work, I'm going to work out the upper and lower bound of each thing. So again, because it's rounded to 10 kilograms, if we half that, it gives us 5 kilograms. So the upper and lower bound for the box that's been delivered is 5 more than 50, so 55, and 5 less than 50, so 45 kilograms. Two things have been taken out of the box. Some books. Now the books, it says, have been done to the nearest kilogram. So if I do 1 kilogram divided by 2, that gives me 0.5 kilograms. So the books, the upper and lower bound for them, are going to be 0.5 above and below what they started with. So 5.5 and 4.5 kilograms. The third item is the guillotine. That is 7.5 kilograms to the nearest 100 grams. So if we take the 100 grams and divide it by 2, as I did with the other bits, that's 50 grams. So 50 grams above and below the 7.5 kilograms will be 7.55 and 7.45 kilograms. Now here I need to work out whether or not it is safe for Mr. Smith to carry this box. So what we need to do is go with the safest possible way of working it out. So in the worst case scenario, the box was not 50 kilograms. In the worst case scenario, the box actually arrived and it weighed 55 kilograms. So I'm going to use the largest value for that. So the 55 kilograms, and we are taking out these two items here. Now again, we're working on the worst case scenario because we want it to be safe. So the worst case scenario is that the books were actually really light. So the lightest they could have been was 4.5 kilograms. And the lightest that the guillotine could have been was 7.45 kilograms. Doing this little calculation, we get the worst case scenario, the heaviest that the box could be, is 43.05 kilograms. We needed the box to be less than 40. So whilst it might be possible that it would be less than 40, it is not a guaranteed. So it is not safe for Mr. Smith to carry the box. The last topic on this video is all to do with quadratic inequalities. Well, in fact, what we're going to do, bearing in mind the little suggestion here, is we are going to have a look at sketching some quadratic graphs to start off with. So if I, for this first one, ignore the fact that it's an inequality and just write it as an equation, we get something that looks like that. If I wanted to try and draw this very, very quickly, or in sketch format, my process would be to start off is to factorise this into double brackets. So to get the x squared, I'd need x in both brackets. Two numbers that times together to make 15, well, that would have to be 5 and 3. And they combine together to make positive 2. So I'd need plus 5, take away 3. Now I'm going to find the solution because that actually represents something quite important when we're drawing the graph. So for x plus 5, so for this bracket to equal 0, my solution would be x equals minus 5. And for x minus 3, for that bracket to equal 0, I would have that x equals 3. So in order to use this, if I draw myself a little sketch, I know, bearing in mind the solutions, that the quadratic graph will cross the x-axis at minus 5 and at 3. This is why we have done this method, so that I know that the graph will look something like that. Now if we go back to the original inequality, it says that we want this to be bigger than 0. So the part of this graph where the graph is larger than 0 is here and here. So the bits above the x-axis. So if x is minus 5 at this point here, all of these points we've got that x will be less than minus 5, so everything over this side, so less than minus 5. And on this one, we want everything that's bigger than 3, so further up the graph than 3, so x is bigger than 3. And these would be the solutions to our inequality. For the second one, we're going to do the exact same thing. So step number 1 is we're going to factorise this. So that would give us x in both brackets. And if we just treat it as an equation just for now, two numbers that times together to make 12, but add together to make 8, well, that would have to be 2 and 6. So the solution, just as I did with this step here, x is going to have to be minus 2, or x is minus 6, in order for these brackets to equal 0. So the reason I've done that, I can now sketch this graph. It will cross at minus 6 and minus 2. Again, graph doesn't need to be drawn accurately, just for the purpose of being able to work out the inequality. Now the inequality said we want that this to be less than 0. So the section where it is less than 0 is down here. So in that section, x is going to be somewhere between minus 6 and minus 2. So in order to write that as an inequality, I want x to be bigger than this minus 6, so bigger than the minus 6, but less than minus 2. So this would be my solution. This is the inequality that would represent this.